Hi everyone, welcome back. In this lecture, we are going to talk about something fundamental in Python, and that is lists. So far, we've seen how to store a single value in a variable, like a name or a number. But what if you want to store multiple values together? That's where Python lists come in. A list in Python is just a collection of items grouped together inside square brackets. Here are the key points you need to know. First, lists are ordered. That means the position of each item is fixed and Python keeps track of the order in which you added them. Look at the visual. You see a row of items: apple, banana, cherry and date, all lined up like boxes on a shelf. Each one has an index number beneath it: 0, 1, 2, 3. This tells us exactly where each item sits in the list. So the first item is always at index 0, the second is at index 1, the third is at index 2 and so on. Python uses these positions or indexes to find, update or remove items later. That's why order matters, because Python remembers it and it never changes unless you change it. So whenever you create a list, remember, you are not just storing data, you are placing each item in a precise numbered position. That's the beauty of ordered collections. Second, lists are mutable. This means once you create a list, you can change it. You can update items, add new ones, remove existing ones, even completely clear the list. Python gives us full control over the content. Let's take an example. Imagine you have a list with these 4 items: apple, banana, cherry and date. Now let's say you want to replace banana with blueberry. In Python, you can do that. You have the power to update any item in the list. You can also add new items at the end, insert them at any position, remove items you don't want, or even clear the entire list if needed. That's what we mean by mutable. The content of the list can be modified anytime. In the visual, you will see banana has been replaced with blueberry. That's a small change, but it shows how flexible Python lists are. So remember this, when you create a list, you are not locking anything in. Python gives you full control to reshape it whenever you want. Third, lists can store different data types. Yes, you can mix strings, numbers, booleans, all in one list. Python doesn't limit you to just one type. Let's look at the diagram. We have a list that holds Alice, which is a string, 30, an integer, true, a boolean, and 3.14, a float. Each of these values has a different data type, but they all live together inside a single Python list. That's the beauty of Python. It's flexible and dynamic. Other languages often force you to use only one type per list, but in Python, you can combine names, ages, status flags, scores, anything, all in one place. This makes list very powerful for storing real-world data where values aren't always the same type. So remember, a Python list isn't just a container, it's a smart container that holds anything you need. Fourth, lists allow duplicates. If you add the same value more than once, Python won't stop you. Let's say you create a list with the values apple, banana, apple, cherry. Notice something? The word apple appears twice, and that's perfectly fine. In Python, a list can contain repeated items. It doesn't complain. It doesn't throw an error. It just stores them in the order you give. Why is this useful? Because in the real world, duplicates happen. You might have repeated names, scores, products, or entries, and Python lists are designed to handle that. Each duplicate is treated as a separate item with its own position or index. So if you ever need to track things that occur more than once, like votes, items in a cart, or daily log entries, lists make it easy. Just remember, in Python, duplicates are allowed, and they are stored exactly as you provide them. Fifth, lists are dynamic in size. This means you don't need to know how many items you will store in advance. You can start with 2 items, then add 5 more, or remove some, and Python handles it smoothly. In Python, you can start with just 2 items, then add 3, 5 or 10 more, and the list grows automatically. Take a look at the diagram. We begin with a list: apple, banana, cherry and date. Then we add one more item, elderberry, and it simply extends the list by 1. No errors, no size limits, no setup required. That's what it means for lists to be dynamic. They expand when you add and they shrink when you remove. This makes Python lists incredibly flexible, perfect for working with real-time data, user input, or anything that changes over time. Next, lists support indexing. Every item in a list has a position, and that position is called an index. In Python, indexing starts at 0, so the first item is at position 0, the second at position 1, and so on. Take a look at the diagram. You will see the list: apple, a banana, cherry and date lined up with their index numbers 0, 1, 2 and 3. This index allows you to access any item directly. Let's say you want the third item, you just refer to index 2. That gives you cherry because indexing starts at 0. This is incredibly useful when working with large lists, when looping, filtering or modifying content. So remember, in Python, every list item has a position, and that position helps you get to the exact item you need. Another key point: lists are iterable. That means you can loop through them one item at a time using a for loop or even a while loop. This is incredibly useful when you are working with a group of values. Let's say you want to print out all the fruits in a list. You don't have to repeat print statements for each one. Instead, you write a loop once and Python takes care of the rest. It goes through the list item by item in order. Look at the diagram. The loop moves from apple to banana, then cherry, and finally date, printing each one in sequence. This concept, iteration, is at the heart of many programs. Whether you are printing menu options, showing high scores, processing input or analyzing results, looping through a list makes your code clean and powerful. So remember, if it's a list, it's iterable, and that makes your programming life a whole lot easier. Lists also support something called slicing. That means you can grab a portion of the list, not just a single item. For example, you might want the first 3 items or maybe just the last 2. With slicing, that's super easy. You simply tell Python which part you want, and it gives you a new list made of just that section. This is really useful when you don't need the whole list. Maybe you want to show just the top 5 scores, the last 3 entries, or everything except the first one. Slicing gives you that flexibility. You can work with parts of a list without changing the original. So keep this in mind. When you are working with large lists or when you are filtering, previewing or trimming data, slicing is your friend. Alright, that wraps up the theory behind Python lists. In the next lectures, we'll dive into actual hands-on code. We'll create lists, access elements, modify them, and use some of the popular list functions. Thanks for watching, and I'll see you in the next lecture.